All right. Hello and welcome to Terminal House Media. I'm the operator, and in today's live stream, the main focus is going to be configuring my GitHub account so that one, I can better myself for the GitHub Foundation certification and also better track my home lab projects. Currently, we're up to 15 subscribers, so thanks for that. And we're going to go ahead and change and update our current task to modify GitHub. All right, so what we're going to do is actually configure GitHub repos. All right, so if you look at I've got the dashboard here, and I can see my top repos, progress tracker, this Rail 9, and this terminal house media server configs. I haven't put anything in there. Let's go make that a little bit bigger for you all to see. So these are the 3 repositories that I have. And if I'm not mistaken, this is connected to my Linux server. So I can open up Hornet's Nest and I go to Alma Linux, and I believe the IP address for this is, I don't remember. So here, do an IPA, then we're gonna grep inet. So 21, and let's see. Here we go. And this is 192.168.121 dashboard projects. So let's see. Projects. Okay, all up to date. So let's see if I go over here to Hornet's Nest, CD. Let's actually do history. So let's find this directory using the find command. Find anything in root with the name. Actually, let's do quotes, Control-V or paste. And to dev null to get rid of any errors. Okay, so I put it in opt. So cd opt Alma. I haven't been on Alma Linux in a while, or Alma Brain. Then let's see, we do an ls. So we've got a readme. Let's do the cat on the readme. Okay. So let's go ahead and focus in. Thank you to our new subscriber. Yeah, go ahead and focus. So I've got a couple of slides that I prepared for this live stream. I'm gonna go ahead and try to pull those up for you. All right. So the first thing that I want to get a lot better at is navigating the web UI for GitHub. One, because like I said at the beginning of this video, I want to track my progress a lot better, and I want to be able to contribute to the community for anybody who may be watching and wants to repeat my labs or what I'm doing, or there's no reason to not share it, so I'm gonna share it. So I'm going to be doing this with Claude. And we're going to bring that up. So I'm saying this is, why is this so zoomed in? Anyways, this is my first set of objectives today. Look at my account on GitHub and let's work together so that I can, prepare for GitHub Foundations, and 2, create an account that's usable and organized for others to view. I will be posting Linux Bash and Ansible scripts. I will also post various server, network, and cloud configurations as I progress through learning and obtaining industry certs. All right, let's make sure Chrome is turned off. So it's gonna probably log into some things. I wanna make sure it's doing the right things. What's your GitHub username profile, or so I can Terminal House Media or similar? I believe it's just at Terminal House Media. GitHub Foundations Prep. What do you want from me right now? Full study plan, quick exam. I am going through the web UI. I pasted an image of my first set of objectives. So allow Claude to fetch pages from raw. Yep. Let's go ahead and exit out of Studio Mode. Sorry for all the transitions. That was OBS. Hello world. All right, pull it up your actual account. GitHub two repos. Yeah, rel 9, 2 commits, just an objectives text, and a one-line README. No actual lab content yet, of course. And progress tracker, 9 commits, and HTML dashboard, 3 stars. Also, one-line README. Bio is generic marketing copy with a YouTube link. No profile README. Oh, there's a YouTube link in here. But right now, a recruiter or another engineer glancing at your profile gets zero signal about what you're building or why. That maps directly to your Section 1 checklist. Profile and repositories are exactly the two things worth fixing first. Since dashboard code, issues, PRs, actions, projects, notifications are mostly UI, you'll just click through as you go. Profile and repositories are the only parts that are actually a product other people look at, and they are also core GitHub Foundation exam content. README goes in a special repo name exactly. Turn on its content becomes the text under your avatar on the profile page. So let's sign in. So let's see. So I go to my profile. All right, confirm. You're signed in as an owner. That unlocks the two things I couldn't do for you before. Your profile now shows edit profile, custom edit, customize your pin, and then a contribution graph. 16 contributions in the last year. No activity yet this week. No profile README repo yet. Here's the actual sequence to do right now in order. New repo name. Name it exactly. Terminal House Media. Must match your username exactly. Public check, add a README file. GitHub auto detects this repo and renders it README as a text block under your avatar on your. I already have a README. No, I have a bio at least. Funny. Oh, I called it Atma Linux, Atma server configs. I want to change the appearance of appearance. There we go. And there we go. Jesus Christ, no. Control K, Control T. Control K, Control T. All right. There we go. Now let's SSH admin at what's geez 168 1 I think it was 21. Yep. All right. Now we're in Alma Brain. All right, so we've got Atlas server configs, progress tracker. And so if we go to profile, and then popular repositories, it's got 3 stars on it. Pretty cool. Let's see if I can pull this.
All of their users get educated and certified so they get the maximum value out of the platform.
The value and the impact that GitHub Custom Learning has on GitHub customers is it provides relevancy and curated content for a specific customer outcome.
Once you're on the path, GitHub Skills gives you the tools to learn by doing, right where development happens. And when you're ready to show what you know, certification is just a few clicks away.
Right, it's really important that all of their users get educated and certified so they get the maximum value out of the platform.
The value and the impact that GitHub Custom Learning has on GitHub customers is it provides relevancy and curated content.
Okay.
GitHub Skills gives you the tools to learn by doing.
Can I stream this? Or am I going to get banned? Obviously, learning with Claude is not going to be right. And it's just going to take me all over the place. So I better just do some structured learning real quick. All right, so we got the terms of services, and I guess it's okay for me to stream this. So we're gonna go ahead and do that. All right. Cool. All right, so we're gonna go ahead and go through this, and hopefully that'll be a lot easier and better. So learn GitHub by doing.
Right where development happens. And when you're ready to show what you know, certification is just a few clicks away.
In software, learning has always been an incredibly important part of what we do. Technology changes so quickly, and these days it's just learn and earn certifications to prove your skill set to employers and companies is incredibly important because it shows that you care about having a growth mindset.
Stronger teams through GitHub Learn. But
I think as a whole, clients with GitHub started off because services.
All right, cool. Got what I need from that. So start your GitHub Learn journey. Yeah, learn from Learn by your self-directed practice. Give skills on GitHub with hands-on learning experiences. Let's go ahead and learn. And credentials, foundations. So we got 5 hours and 49 minutes, then 4 hours and 57 minutes. Cool. Start learning. GitHub Foundations. Part 1 of 2, beginner, intermediate. Let's do it. The GitHub Foundations learning path, part 1 of 2, is a concise and beginner-friendly journey designed to introduce you to the fundamental concepts and products of GitHub. You'll discover the benefits of using GitHub as a collaborative platform and explore its core features such as repository management, commits, branches, and merging. So the slides that I had earlier, screw that, because this is more guided learning, and I'd rather just do this versus making up a mile with some whack AI, which is not too whack right now because there is a video. Let me go to my history real quick.
1X reveals tendon-driven humanoid hands for the Neo for 25 degrees of freedom.
Let's see. Let's do it like this. Let's copy that. And new tab. Paste and go. Alright, so I thought this was kind of crazy. I can see all the things that it can do. Oh, this is where it gets a little wild.
He's already better than me.
Yeah, so some of AI is not good, and then some of it is like, oh boy, it's really coming for our jobs. So 3 minutes. Imagine you're a new software developer at a firm that writes avionics software for commercial airliners. Quality control is critical, and developers work in small teams using Git for version control. You've heard of version control, but you've never used Git, so you're eager to catch up. You decide to learn Git by working through a hands-on exercise where you create a repository, make commits, explore history, and experiment with branches. But before diving headfirst into Git, you must cover the basics. In this module, you'll get an introduction to version control and Git. Git can seem a little cryptic at first, and it can even be frustrating at times, which is why I'm going through this again. But if you learn it step by step, you'll find that there's a reason Git is the world's most popular version control system, not just for software developers, but also for teams that write documentation and collaborate on other work. Watch a video for overview of the exercise in the module, see the video, and learning objectives. In this module, you'll learn what version control is, understand distribute version control systems like Git, configure your Git identity and create a new Git project, make and track changes to code by using Git, work with branches to experiment safely. Prerequisite, have a GitHub account, already have that. Basic familiarity with using a command line interface, got RHCSA, and a code editor such as Visual Studio Code, and you just saw me waste a lot of time on configuring that. So let's go to this video. It's 18 minutes.
Hi, everyone, and welcome back to another episode of Learn with Dr. G. That's
Hello, Dr.
me.
G.
Today, we're going to be doing a quick recap on the Intro to Git live stream that we did previously. So stick around.
All right, bet.
So we did a live stream where we introduced Git following along on this Git module at aka.ms/learnwithdrg/intro to Git. There were a couple of questions, and I also just wanted to do a quick short recap of what we learned. So I've created a short PowerPoint deck to visualize what we're going to be doing in the terminal. Now, if you followed along on the Learn module, you know you get to actually use a terminal that's in the sandbox inside of Learn in the browser. In this case, I'm going to be using Windows Subsystem for Linux and Ubuntu terminal right here on my machine. Same thing though. So the first thing that we need to do is some setup.
So do I watch this video first, or do I go through here? Let's see. Oh. All right, so let's go ahead and do some reading then before we listen to her. No offense to her. Oh, seems like it's going to be a fast-paced video. Very fast-paced. I'm not good with fast-paced. Let's get our music back. All right, so what is version control? A version control system, VCS, is a program or set of programs that tracks changes to a collection of files. One goal of a VCS is to easily recall earlier versions of individual files or of the entire project. Another goal is to allow several team members to work on a project even on the same files at the same time without affecting each other's work. Version control is often discussed as a part of software configuration management, SCM. The two terms sometimes are used interchangeably. In fact, Git's official documentation is located at gitscm.com. Technically, version control is just one of the practices involved in SCM. A VCS, a version control system, can be used for projects other than software, including books and online tutorials. With version control systems, you can See all the changes made to your project, when the changes were made, and who made them. Include a message with each change to explain the reasoning behind it. Retrieve past versions of the entire project or of individual files. Create branches where changes can be made experimentally. This feature allows several different sets of changes, for example, features or bug fixes, to be worked on at the same time, possibly by different people without affecting the main branch. Later, you can merge these changes you want to keep back into the main branch. Attach a tag to a version, for example, to mark a new release. Git is fast, versatile, highly scalable, free, open source version control system. Its primary author is Linus Torvalds, the creator of Linux.
Imagine your team develops a web application and a teammate introduces a bug while implementing a feature. Thankfully, your team has version control, which enables you to track changes and revert to a bug-free code base. Version control is a safety net for coding projects and documents. Version control tracks changes to your code in a central repository. Every time any change or milestone is reached, version control takes a snapshot called a commit. Each commit represents a different project stage, allowing you to see how work has evolved. Version control also helps manage merge conflicts so you can resolve any issues and keep things running smoothly. This enhances collaboration by tracking changes, providing work history, and managing teamwork. For example, consider a software development team building an e-commerce website. Front-end and back-end developers, as well as UI/UX designers, use Git for version control. They create separate branches for features, bug fixes, and design updates to avoid interference. One developer creates a product recommendation feature while another improves search functionality, each in their own branch. After testing, they merge their changes into the main codebase. Conflicts are resolved, and changes are reviewed before merging.
I'm sorry, I have ADHD, and I just really thought about something. Can Claude run on Linux? Is there an app that will work on Alma Linux? Oh, you can't see my Claude, sorry. I'm going to pause that real quick because sometimes my ideas start to flow. Let's see. So Claude Desktop GUI with Jacko where code tabs. What you're using right now is Linux beta, but only supports Ubuntu. Oh boy, we're about to do this real quick. Side project. Who cares? I'm just gonna be online all night, so I got time to waste. If you guys watch this, thank you. If you don't, it's okay. But this is how my thinking works. So then I'm gonna keep on going. All right, so I'm gonna go back to Visual Studio Code. Actually, go to my browser and what specs are needed to get this to run on Ubuntu. I am going to run a VM. So we need 8 gigabytes of RAM, 25 gigabyte disk, and KVM enabled, host, CPU, Proxmox VM. So I'm gonna go ahead and try to do that real quick. Let's go to Proxmox and let's look at Hornet's Nest summary, see what space we're working with. RAM, 8 gigs. That's what I said, right? Gigabytes of RAM, 25 gigabyte disk. All right, so let's create a new VM. We're gonna call this Claude Next OS. Gotta get through Ubuntu. Good, then that one. We need Ubuntu 22 plus. All right. All right, there's an Ubuntu cheat sheet. You can download that. I'm not gonna put that information there yet. But I'll keep that up. Let's see. Looks like this is downloading pretty fast. This is AMD server though. And if I look at the notes, Ubuntu 22 plus x86 or ARM64. And what's downloading? Oh, I think what we needed was the desktop. ARM 64-bit. Oh, I guess it could have been x86 or ARM 64. Let's go back. guess we're just downloading all these, whatever. Let's see, Claude, Ubuntu. Oh boy, we are cooking. Claude Desktop on Linux Beta, Ubuntu 20, okay, x86 or ARM64. All right, so now I'm gonna upload this ISO image to Hornet's Nest actually before creating this ISO or server. Let's go ahead and get rid of, let's remove this, we don't need that. Sometimes when you have too many ISOs in here, it starts to eat up space on your host. All right. Yeah, that might take a second. All right, so while that's going on, back over here. Oh no! It's all right, we can bring it back up, go over, and cool. I prefer it the other way around. There we go. Okay, so I did not pay attention to this video because I started getting ideas. And we're going to play this video again.
Imagine your team develops a web application and a teammate introduces a bug while implementing a feature. Thankfully, your team has version control, which enables you to track changes and revert to a bug-free code base. Version control is a safety net for coding projects and documents. Version control tracks changes to your code in a central repository.
Okay, a central folder.
Every time any change or milestone is reached, version control takes a snapshot called a commit. Each commit represents a different project stage, allowing you to see how work has evolved. Version control also helps manage merge conflicts so you can resolve any issues and keep things running smoothly. This enhances collaboration by tracking changes, providing work history, and managing teamwork. For example, consider a software development team building an e-commerce website. Front-end and back-end developers, as well as UI/UX designers, use Git for version control. They create separate branches for features, bug fixes, and design updates to avoid interference. One developer creates a product recommendation feature while another improves search functionality, each in their own branch. After testing, they merge their changes into the main code base. Conflicts are resolved, and changes are reviewed before merging. If a bug is introduced, they use Git's commit history to identify when and where the issue occurred, revert to a stable version, fix the bug, and merge the changes back. Version control allows teams to track changes, maintain work history, and collaborate effectively. Using systems like Git, developers can work on separate branches, merge changes, and resolve conflicts, ensuring a smooth development process and a stable end product.
This video was created with the help of artificial intelligence. Learn more about our principles for AI-generated content at aka.ms/AI content principles.
Okay. Name something that's not created with the help of artificial intelligence. All right. Distributed version control, centralized version control systems, including CVS, Subversion, SVN, and Perforce use a centralized server to store a project's history. This centralization means that the one server is also potentially a single point of failure. Git is distributed, which means that a project's complete history is stored on your local computer, and when you use one on a server, you can edit files without a network connection, commit them locally, and sync with the server when a connection becomes available. If a server goes down, you still have a local copy of the project. Technically, you don't even have to have a server. Changes can be passed around an email or shared by using removable media. Almost most teams today use a remote host repository. What am I looking for? My notes. Sorry, I'm looking for... Here we go. All right. We're doing a lot of work here. That's how my brain works. This is not good. All right, so Git is distributed, which means that project's complete history is stored on changes. Okay, Git terminology. This is it. This seems like some kind of spy stuff. Like, we actually didn't get rid of the. Oh, let's pull this up. Here we go. And got Chrome up. There we go. The internet. Anyway, so this paragraph seems almost like it would be in a spy movie, as though they were trying to get rid of code and couldn't get rid of it because it's distributed, and someone still has it on like a computer locally saved. All right, Git terminology. They can always upload it. Anyways, Git terminology. To understand Git, you have to understand the terminology. Here's a short list of terms that Git users frequently use. Don't be concerned about the details for now. All these terms will become familiar as you work through your way. All these terms will become familiar as you work your way through the exercise in this module. Let's see. All right, so first we have working tree, the set of nested directories and files that contain the project that's being worked on. The set of nested directories and files. Then we have repository, the data store contained in a hidden directory named .git at the top level of a working tree. Oh. Let's clear cd opt, cd alma, copy, there we go. ls-lah to view the hidden files. Yep, there's a .git. I guess the important thing about being able to have a skill is to being able to repeat it. Kind of forgot some of the stuff I did. I did this so long ago. All right, at the top level of working tree, where Git keeps all the history and metadata for a project. Repositories are almost always referred to as repos. A bare repository is one that is part of working tree. It's used for sharing or backup. A bare repo is usually a directory with a name that ends in .git. For example, project.git. Okay, then we have hash, a number produced by a hash function that represents the contents of a file or another object as a fixed number of digits. Git traditionally uses SHA-1 hashes that are 160 bits long, though modern versions of Git also support SHA-256. Oh, wow. Oh, they do support. Okay. Traditionally uses SHA-1. Okay, so that's safer. Anyways, one advantage to using hashes is that Git can tell whether a file has changed by hashing its contents and comparing the results previous. of the previous hash. It's if the file time and date stamp is changed, but the file hash isn't changed, Git knows the file contents are changed. Gonna copy these into ChatGPT and make some visuals of these. Oh my goodness. All right. Okay, so then we have the hash. Okay, and then the object. A Git repo contains 4 types of objects, each uniquely identified by a hash. A blob object contains an ordinary file. A tree object represents a directory. It contains names, hashes, and permissions. A commit object represents a specific version of the working tree. An annotated tag object stores metadata such as a name, message, and optional signature, and usually points to a commit, though it can point to other Git objects as well. Git supports lightweight tags, which are references rather than objects. Commit. Okay, there we go. That's what I want. Okay, so we have commit. It means you are committing the changes you have made so that the others can eventually see them too. A branch is a named series of linked commits. The most recent commit on a branch is called the head. The default branch, which is created when you initialize a repository, is called main. On GitHub and many other platforms, the head of the current branch is named head. Branches are incredibly useful features of Git because they allow developers to work independently or together in branches and later merge their changes to the default branch. So we got head, which is the latest commit, and main, which is your original starting point. I'm saving the slides so that we can view them together. Okay. All right. And then, okay, so we have object, commit, branch, remote. A remote is a named reference to a Git repository. When you clone a repo, Git creates a remote named origin that points to the repository you cloned from. Origin is the default remote for push and pull operations. Okay. Then we have commands, subcommands, and options. Git operations are performed by using commands like git push, git pull. Git is the command and push or pull is the subcommand. The subcommand specifies the operation you want Git to perform. Commands frequently are accompanied by options which use hyphens or double hyphens, hyphen. For example, git reset hard. These terms and others like push and pull will make more sense shortly, but you have to start somewhere, and you might find it helpful to come back and review this glossary of terms after you finish the module. The Git command line. Several different GUIs are available for Git, including GitHub Desktop. Many programming editors like Visual Studio Code also have an interface to Git. They all work differently and they have different limitations. None of them implement all of Git's functionality. Well, that's stupid. Why don't you create something that does? Can we exclamation mark on that? Like, again, that's stupid. Create something that does. All right, then the exercise in this module uses a combination of the Git command line and Visual Studio Code and a GitHub Codespaces environment. Git command line interface works the same no matter what operating system you're using. Plus, the command line lets you tap into all of Git's functionality. None of them implement all of Git's functionality. Plus, the command line lets you tap into all of Git's functionality. Interesting. Developers who see Git only through a GUI sometimes find themselves confronted with error messages they can't resolve, and they have to resort to the command line to get going again. Git and GitHub. As you work with Git, you might wonder about differences between the features it offers and the features offered on GitHub. As mentioned earlier, Git has a distributed version control system, DVCS, that multiple developers and other contributors can use to work on a project. It provides a way to work with one or more local branches and then push them to a remote repository. Let's pause there and check on our ISO upload. It's done. Ooh boy, now we're cooking in the kitchen. Cooking. Create a VM. I'm gonna call this Claude. Nah. Let's think. Let's think. I want a good name for this server. AI 01. Let's see, we got ChatGPT, Claude. Oh, there's two C's. So we'll do Claude AI, and then with the host name I'll actually make AI01, but I'll do Claude AI01. Ooh boy, let's see what we can do. Okay, 1.2.26.0. Excuse me. I could do this stateless, but do I want to? No, I want the server to always be up and I want it to retain memory, so obviously not. All right, so yeah, I'm just gonna roll with creating a VM, and let's see where this idea takes me. So basically what I wanna do is I want to run Claude within a virtual machine. My server always stays up. I'm constantly turning off my personal PC, and since I have co-work enabled, I might as well run Claude on a VM and allow it to do work overnight for me. So that's why we're creating this virtual machine, taking a divot from GitHub. We'll get back to the GitHub, but I want to set this up real quick, and then I'll continue with my GitHub reading. Whoa, let's see if this works. Okay, so machine, Q35, BIOS, UEFI, storage, local. Did it say to activate QEMU agent or not? KVM just say enabled host CPU. Y'all, let's get it. So we're gonna leave that as is and go to next disk. Bare minimum, fam. Bare minimum. I just need you to do some jobs. And cores, I think we were gonna give it 2. Put it on the host. A lot of stuff is just running off on the host. I'm not sure how good that's going to be moving into the future. Then memory, it's at 8 gigabytes. So what is it? 8192. Then bridge, virtual manager bridge 0. Yeah. I mean, yeah. We'll just leave it on this bridge. Yeah, I don't want a lot of things touching my stateless environment, my werewolf environment, so I'm leaving it on virtual management bridge 0. No VLAN, keep it parallelized, confirm. Go ahead and start after boot and finish. I think that's a pretty good name. Claude AI 01. Maybe there'd be a. Oh, let's see. What other AI agents can run on Linux distros? Do that and you think, because you take forever to think. Okay, so as you work with Git, you might wonder about differences between the features it offers and the features offered on GitHub. As mentioned earlier, Git is a distributed version control system, DVCS, that multiple developers and contributors can work on a project. It provides. GitHub is a cloud platform that uses Git as core technology. GitHub simplifies the process of collaborating on projects and provides a website, more command line tools, and overall flow that developers and users can use to work together. GitHub access remote repository mentioned earlier. Key features provided by GitHub include issues, discussions, I like that, pull requests, notifications, labels, actions, forks, projects, Copilot, code spaces. To learn more about GitHub, see the introduction to GitHub, learn module, or get started with GitHub. What is this? Introduction to GitHub Foundations. Gotcha. All right, next exercise, try out Git. Exercise, try out Git. This exercise checks your knowledge of Git fundamentals, including version control concepts, configuring your identity, creating and committing repositories, exploring history, working with branches, and basic collaboration workflows. When you select the Start Exercise on GitHub button below, you'll be taken to a public GitHub template repository. Select the Copy Exercise button on that page to copy the exercise to your own account, then complete a series of small challenges. All right, let's go ahead and start the exercise. And then set the consume it, Isaiah. Operator. Whoa. Start the exercise on GitHub. Select copy exercise on the page to copy the exercise to your own account. Then complete a series of small challenges. All right, start the exercise. Where's this say copy? All right, so here we are on the page. Then it says to say copy. Oh, here we go. How to start this exercise? Well, let's read it first. Introduction to Git. Use Git version control to work on a game using command line interface in VS Code. Who is this for? Beginner developers who want to learn Git version control. Well, you'll learn fundamental Git concepts, including commits, branches, history, and collaboration basics. What you'll build, you'll create a Git repository, add a sample code, then develop some simple features. Prerequisites: no prior Git or version control experience required. Recommended basic familiarity with command line interfaces, CLI, and recommended basic familiarity with Visual Studio Code. I got that pretty much, kind of. How long? This exercise takes less than 60 minutes to complete. In this exercise, you'll understand what version control is and why developers use it, configure your Git identity, create your first repository and make commits, version, view project history and compare file changes, work with the branches to experiment safely. Learn about Git collaboration concepts. All right, let's copy exercise. Oh, let's see what we can create. Skill introduction to Git. Of course, we're just going to leave it as that. So create a new repositories, container projects files, and version history. Have a project elsewhere. Cool. Start with a template. Yup. Include all branches. Enable all branches from template history repository. No. Great. Okay. Description, exercise, intro to Git, configuration, choose visibility, public. Yeah. You guys see what I'm working on. Generating your repository. It's 11:30. 11:30 at night. Okay. So that step is done. And that's funny. That was I should have opened that in a new tab. The repositories, because I already did this. Skills intro, introduction to Git. Cool. So back to the exercise next. All right, so basic Git commands. Git works by remembering the changes to your files. If it's taking snapshots of your file system. Let's review a few basic commands you use to track files in your repo and save snapshots for Git to compare against. We have Git status. The first and most commonly used Git command is Git status. It displays the state of working tree of the staging area, also known as the index. Let's inspect, modify, stage, it lets you inspect modified, staged, and untracked files so you can decide what to do next. So I'm gonna bring up Visual Studio Code, and what was it? Get status failed. Exception call. Well, that's a problem. All right, what was the last question? What other AI agents can I run? I mean, since they're almost all terminal native, they run the OpenAI's Codex. Since that pattern is how privilege escalation works via Git hooks. I'd rather just be admin and just learn how to do it the right way. So we're going to sue and become admin, clear cd opt. And what is it? All right, get status. Cool. So apparently you can't be using Git as someone who is not the owner of the directory, unless you do the I trust everybody and I don't trust everybody. That's too valuable and real of a statement. Go ahead and put the rest of these commands in here. So it's hash object. We got git add is the command you use to add file contents to the staging area. The technical term is staging these changes. You use git add to stage new files for the first commit and to stage later changes to files Git already knows about. All changes you stage with git add are stored in the staging area until you commit them. Git commit. After you've staged some changes for commit, you can save your work to a snapshot by invoking the git commit command. Commit is both a verb and a noun. It has essentially the same meaning as when you commit to plan or commit to change to a database. As a verb, committing changes means you put a copy of the file directory or other stuff in the repository as a new version. As a noun, a commit is the small chunk of data that gives a unique identity to a particular snapshot of your project. The data that's saved in a commit includes the author's name and email address, the date, comments about what you did and why, an optional digital signature, a reference to save snapshot, and the parent commit or commits, if any. Then we have git log. The git log command allows you to see information about previous commits. Each commit has a message attached to it, a commit message, and its git log command prints information about the most recent commits, like their timestamp, the author, and a commit message. The command helps you keep track of what you've been doing and what changes have been saved. Then we have git help. Everybody needs help. Use the git help command to easily get information about all the commands you learned so far and more. Remember, each command comes with its own help page too. You can see these help pages by typing git command -help. For example, git commit -help brings up a page that tells you more about git commit commands and how to use it. Alright. Still creating these images. I do a lot of things at one time. All right, we got a module assessment, 5 minutes, 200 XP. Oh boy, they gamified this learning experience. All right, which of the following scenarios is a common use for version control? Gathering feature requirements for a large project and communicating them to stakeholders. Note, deleting earlier versions of project files so you know you are working only with the most current file or data, making experimental changes in isolated branch. All right. Which broader discipline commonly includes version control? Broader discipline. Software control management system, software configuration management system, version management system. What's the difference between Git and GitHub? Git lets you work with more local. Git is used in. Oh boy. Git is a distributed version control system that runs in the cloud. Nope. Git lets you work with one or more local branches and push changes to a remote repository. GitHub access the remote repository, which is accessed through a website or command line tools. Yes. What git command gives information about how to use git? Git help. Submit answers. Nah, I figured it would be this one. So it's software configuration management. You're not gonna tell me why I got it wrong. Achieve 100% to pass. 100% to pass. Click retake or try again. Yeah. How about retake? So it's just going to be the same exact test again. That's cool. All right, I knew it was SCCM something. So software configuration management system. That was a little play in there, a little joke in there. Okay, then we got branch. All right, summary. Congratulations. In this module, you learned the basics of using Git. You learned an overview of version control system, important Git terminology, the difference between Git and GitHub, how to configure Git, some basic Git commands. At this point, you know enough about Git to use version control by yourself on a basic project. Collaboration with other developers is where the version control shines. Check out where other modules in this learning path or more using with Git resources. Is that it? Everything is local. Let's create a new repository to see where you are, to see what happened, and get branch. Let's try something, shall we? So if I go cd back and I make dir, and I'm going to call this test, whatever, who cares? Sudo make dir test, cd test, and what was it? Git init, sudo git init. Oh wow. And chown -r admin on test, and oops, sudo, and then git status. Wow. All right. cd dot and git delete. Can I do git remove? Oh, I just created another repo for no reason. So let's go back over, and we're gonna go back to GitHub. Gonna go to my profile, repositories, and it's not there. Awesome. Okay, so back to the training. Okay, so we get this everyday Git. That's cool. Review GitHub learning resources. Introduction to GitHub recap documentation. We already did all that. So now we're ready for the video.
We're going to start by configuring our username and email. This will help Git know who is making what commits or saves of the file. You can see an explanation here. All right, so it looks like we set our username and our email.
Whoa, sorry. Let's just go ahead and
following along on this Git module at aka.ms/learnwithdrg/intro to Git. There were a couple of questions, and I also just wanted to do a quick.
I want to go to the site. All right. So I guess that'd be a new tab. So https://aka.ms learn. We can get this music back on, that's fine. What is it? Learn with Dr. G. Take out these subtitles. Intro to Git. Intro to Git. I already did this. I didn't really feel like that training was I don't know. It was all right. Could have been better a little bit. It's having me create an account to save my progress. All right. All right, cool. So first, let's share your achievement. We can do that another time. All right, so then what's next? GitHub part 1 out of 2. That's a plan. I thought I already started this. Okay. This module introduction module explores responsible use of AI in the context of GitHub, Copilot, a generative AI tool for developers. It equips you with the knowledge and skills to use Copilot effectively while mitigating potential ethical and operational risks associated with AI usage. By the end of this module, you'll be able to where was I at? Sorry, I got a notification. By the end of this module, you'll be able to understand and apply principles of responsible AI usage, identify limitations and mitigate risks associated with AI, learn best practices for ensuring AI-generated code aligns with ethical standards and project-specific requirements, recognize the importance of transparency, accountability in AI systems, and building trust and maintain user confidence. Mitigate AI risk. Artificial intelligence presents numerous opportunities for innovation and efficiency, but it also comes with significant risks that need to be carefully managed. One of the primary concerns is that AI systems can sometimes make decisions that are difficult to interpret, leading to a lack of transparency and accountability. Additionally, AI can result in unintended and harmful outcomes such as biased decision-making or privacy violations. To mitigate these risks, it is essential to implement robust governance frameworks, ensuring transparency in AI processes, and incorporate human oversight. By doing so, organizations can harness the benefits of AI while minimizing potential negative impacts. In the next section, we'll discuss this concept of responsible AI and how to apply its principles to reduce the risk associated with AI tools like GitHub Copilot. What is responsible AI? I don't know. You're going to tell me, aren't you? Responsible AI is an approach to developing, assessing, and deploying artificial intelligence systems in a safe, trustworthy, and ethical way. AI systems are the product of many decisions made by the people who develop and deploy them. From system purpose to how people interact with AI systems, responsible AI can help proactively guide these decisions towards more beneficial and equitable outcomes. That means keeping people and their goals at their center of design decisions and respecting enduring values like fairness, reliability, and transparency. In the next unit, we'll cover Microsoft and GitHub's 6 principles of responsible AI. Microsoft and GitHub's 6 principles of responsible AI: fairness, reliability and safety, privacy and security, inclusiveness, core principles, transparency, accountability. Microsoft is a global leader in responsible AI, identifying 6 key principles that should guide AI development and usage. These principles are fairness. AI systems should treat all people fairly. Reliability and safety. AI systems should perform reliably and safely. Privacy and security. AI systems should be secure and respect privacy. Inclusiveness. AI systems should empower everyone and engage people. Transparency. AI systems should be understandable. Accountability. People should be accountable for AI systems. Now let's explore each of these principles in greater detail to understand how they guide responsible AI practices. Fairness. AI systems should treat all people fairly. AI systems should treat everyone fairly, avoiding differential impacts on similarly situated groups. In contexts like medical treatment, loan applications, or employment, AI should provide consistent recommendations to individuals with similar symptoms, financial situations, or qualifications. Employs techniques to detect bias and mitigate unfair impacts, such as reviewing training data, testing models with balanced demographic samples using adversarial but debiasing, monitoring model performance across user segments, implementing controls to override unfair model scores, training AI models on diverse and balanced data can help reduce biases, ultimately promoting fairness. Reliability and safety. AI systems should perform reliably and safely. Okay, let's see if my AI is going to perform reliably and safely. Let's check her in real quick. We got Claude AI going. Are you up? Yep. Let's boot into English. Accessibility, we need none of that. English. Use a wire connection. Do not connect to the internet. Yeah, whatever. Install Ubuntu alongside instead of your current operating system. No, install it. Nope. Interactive install. Oh, let's do. Yep, just default. Yep, download, install different media formats. Yep. How do you want to install Ubuntu? Erase disk and install Ubuntu. Encryption in file. Yeah, we don't need encryption. Your name, admin, your computer's name, Claude _ AI, Claude, your username. Okay, we're going with operator. Oh my goodness. Your name is gonna be Claude. Cool. I don't care about the password. New York. Install. All right. Let's keep on reading while that installs. Back to our documentation. Nope. Oh, we got so many tabs. Oh, up here. Nope. Yep. All right. Reliability to safety. AI systems should perform reliably and safely. To build trust, AI systems must operate reliably, safely, and consistently. These systems need to function as designed, respond safely to unexpected conditions, and resist harmful manipulation. Their behavior and the variety of conditions they handle reflect the foresight of developers during design and testing. Safety in AI refers to minimizing unintended harm, including physical, emotional, and financial harm to individuals and societies. Reliability means that AI systems perform consistently and intended without unwanted variability or errors. Safe and reliable systems are robust, accurate, and behave predictably under normal conditions. I feel like the demands of this file are not the reality of what exists inside of actually using AI. All right, so then we got privacy and security. AI systems should be secure and respect privacy. As artificial intelligence becomes more common, it's important to protect user privacy and data security. Microsoft and GitHub are aware of this tenet. Both companies include privacy and security as key parts of their responsible AI plan. This plan focuses on using principles to guide data practices. Microsoft and GitHub's approach to responsible AI aims to stop abuse and keep user trust. Key points include getting users permission before collecting their data, clearly explain how the AI uses their data, and get their consent. Don't collect data secretly. Let users choose if they want to share their personal data, and inform them through clear prompts and policies. Collecting only the data that needed for AI to work. Avoid gathering extra information and remove sensitive data once the AI is in use. Regularly check data inputs to ensure only essential data is collected. Anonymizing personal data. Use methods like pseudonymization. Okay, we're going to pronounce that. Oops. Personal details with random identifiers by aggregation groups data into summaries, removing specific individual details. Encrypt sensitive data both during transfer and when stored. Use strong encryption methods and secure keys through hardware security modules. HSM which store keys in a tamper-proof environment. Secure vaults like Microsoft Azure for key storage with controlled access. Envelope encryption, which uses 2 keys for added security. And then organizations should control who can access keys, and modules rotate keys regularly and securely back up keys. They should also limit employee access to sensitive models and data, classify them based on sensitivity, and conduct regular security audits to prevent unauthorized access. Inclusiveness. AI systems should empower everyone and engage people. Let's see what this sounds like. Pseudonymization. They said it like I was. Pseudonymization. All right. Microsoft Responsible AI Standard for Inclusiveness means all AI systems work well for diverse users and groups. They don't disadvantage some people. AI systems are accessible. Anyone can use AI systems easily, regardless of physical or mental disabilities. AI systems are available worldwide, even in developing countries/regions. AI systems can't exclude certain geographies. People are from different backgrounds and communities provide input into the development of AI systems. AI systems allow all users to benefit equally from their capabilities. They must empower everyone. Examples of inclusive AI include facial recognition that works across skin tones, ages, and genders, interface that supports screen readers for visually impaired, language translation that supports small regional dialects, teams that seek diverse perspectives when designing systems. Microsoft Responsible AI Standard require that everyone can access AI systems, regardless of their disability, language, or infrastructure barriers. Responsible AI solutions must enable full global inclusion by offering alternative modes of interaction such as voice control, captions, and screen readers, supporting adaptation into different languages and local cultural contexts, working offline and with limited connectivity and computing resources. Transparency. AI systems should be understandable. Microsoft's Responsible AI principle of transparency emphasizes that AI systems must be understandable and interpretable. AI creators should explain how their systems operate clearly through a clear validation framework, justify the design choices behind AI, systems, be honest about capabilities, transparency, be honest about capabilities and limitations of AI systems, enable auditability with logging, reporting, and auditing capabilities. Transparency is essential to build trust, ensure accountability, promote fairness, enhance safety, and support inclusiveness. Implementing transparency involves documenting in data and models, creating explanatory interfaces using AI debugging tools, constructing testing dashboards, and enabling logging and auditing by being transparent. By being transparent, AI creators can foster trust and responsible AI use. All right, last section, and then we're going to take a little break. Accountability. People should be accountable for AI systems. The accountability principle states that AI creators should be responsible for how their systems operate. They need to continuously monitor systems performance and mitigate risk. Accountability in AI industry is becoming a pressing issue. Excuse me. Sorry about that. As high-profile cases of algorithmic harm, bias, and abuse come to light, critics increasingly argue that without accountability, AI creators hold too much power over opaque systems impacting lives. Microsoft emphasizes accountability in AI development and deployment through its responsible AI standard, which considers accountability a foundational principle. According to Microsoft, AI systems must be accountable to people, and companies deploying AI systems must take responsibility for their operation. Now let's do the knowledge check to review what we just learned. All right, module assessment. Choose the best response for each question. Check your knowledge. What is the primary goal of responsible AI? Maximize profits from AI systems. That would be nice. To develop AI systems as quickly as possible. Probably not, because it would be a lot faster if that was the case. To ensure AI systems are safe, trustworthy, and ethical. To replace human decision making with AI. That's probably the further go down the line, right? All right. Then, which principle is not one of the 6 identified by Microsoft for responsible AI? I think innovation. What does the principle of fairness in responsible AI emphasize? Ensuring AI systems perform equally well across all demographic groups. How does Microsoft address potential biases in AI systems? By reviewing training data, testing with balanced samples, and using adversarial debiasing. What is the role of transparency in Microsoft's responsible AI principles? What is the role of transparency? To make AI systems, operations, and decisions understandable and clear. Why is it important for developers to closely scrutinize AI-generated code to reduce the development time, to ensure that the code aligns with project-specific conventions and requirements, to enhance creative aspect of coding, to automatically improve system performance? Submit answers. Did I get anything wrong? 100%, yo. 100%. That's what we're talking about. 100% at 12 a.m. in the morning. Summary. Microsoft and GitHub are leaders and innovators in the AI space. We're committed to ensuring that AI systems are developed and used in ways that are safe, trustworthy, and ethically sound. 6 core principles guide our approach: fairness, reliability, safety, privacy and security, inclusiveness, transparency, and accountability. Our goal is to ensure that AI systems prioritize people and uphold fundamental values like fairness, reliability, and transparency. We also encourage other organizations to adopt these standards, and we hope that by providing resources like this module, we can help developers create effective, safe, and transparent AI solutions. All right, let's go ahead and we're going to take that much needed break. Got another completed module. So we did 2 modules in one night. So that means I'm 4% done. And which one would this be? We already did this. So this is not going to take me to the next module. Oh, this is the next module. Let's go back. Sorry about that. And let's go back. Back. Okay. Oh, I didn't take the assessment yet. Oh, I see. Okay. This is a 20-minute thing. All right, we're gonna introduction to GitHub Copilot. That's actually what I need. That's the whole point. It took me through this. God, treating this like a college course. So we're going to take a break, and then I'm going to come back to this 20 minute. No, I'm going to start off with the introduction. All right. Do I want to do this tonight? Pretty much, but I didn't really. I mean, progress is progress, right? We did get some things done. We got here. Introduction to Git. Oh, okay. So I guess this is we should have done this and then do the GitHub shell 41% Java, CSS, HTML 7.4%. Contributors. All right, that's cool. All right. Let's go ahead and take a 10-minute and gather our thoughts, and then we'll get back to some more studying. Testing 1, 2, 3. All right, I'm back. I'm not gonna take the full 5-minute. So what I'm gonna do is I'm gonna save introduction to Git and GitHub Copilot. I'm gonna save that for tomorrow morning. And what I'm gonna do for this stream, how I'm gonna finish out this stream rather, is going back over to Proxmox. I'm gonna finish the installation for Ubuntu. Gonna go over to hardware and let's get this network device. Gonna copy this MAC address and I'm gonna add that to my router. That way we can keep a static configuration of this server. And I'm doing this on another screen because it is, don't want to give all that stuff away, right? So we go to console. Looks like it's coming up. All right. So we've got Ubuntu 26 installed, I believe. Type in our password, log in as Claude. And I'm going to go ahead and bring up the terminal. Excuse me. Yeah. Welcome to Ubuntu 26. Let's go with dark mode. And we'll finish that and let's get our terminal opened up. And let's see, is it IPA? Cool. So we got an IP address of 192.168.1.10. So I'm gonna add that into here. On my router 10. And the MAC address and the device name is actually Claude. And we're gonna add that in. This way, when the server reboots, it'll always have that MAC address coming from my router. Cool, and that worked. All right, so now I'll bring up Visual Studio Code and I'm going to SSH Claude at 192.168.1.10. Exit. SSH Claude at 192.168.1.10. Ping 192.168.1.10. What? So I can ping it, but I can't SSH to it. That's a little odd. Sudo and clear cd etc ssh hello cd ssh config. Oh nope, cat ssh config. It's commented out. Vim, Etsy, SSH. Oops. CD. Oh, you know, SSH config. All right. And password authentication. Yes. And then Control X, Control Y, enter. System, UTL, restart, SSH. And save now. Can I SSH in? Exit. SSH 192.168.1.10. SSH Claude. Huh. SSH hyphen 4VV Claude at 192.168.1.10. All right. All right, let's add Claude to this real quick. For whatever reason, that distro did not ship with SSH installed, so that's interesting. See, and that's the thing that would be great for a bash script. Basically how to get SSH enabled from console to terminal. But let's just go back over. All right. Get started. Nope. Desktop. And I'm going to be running some of these commands. So I'm going to do this in Visual Studio Code. So we got sudo apt install curl. And then download Anthropic signing key. Okay, register the repository. And then install the package. All right, launch and sign in. Launch Claude from your application launcher or run Claude Desktop from a terminal and sign in with your Anthropic account. All right. So I'll show you Visual Studio Code. You can see that's what I did. Just went through those basic commands that have already been shown on the screen. All right. Now, let's use Claude on a Linux virtual machine. Yeah, we'll close that window and we're looking for Claude. Home, desktop. All right. Well, then let's do it the old-fashioned way. Terminal. And what the instructions say? Claude desktop. Claude -desktop. Oops. I guess I didn't finish the installation. Awesome. Cool. Now, let's go back over to our console and see first if we can open it through the launcher. Oh, there it is. So beautiful. Okay. I am going to turn off my screen. And clear. We can do cool. And while that's doing that, we're gonna go ahead and get started. And how did I log into? Let's do a login with email. Yes, into a verification code is so much easier. All right, so we got Claude working. We're signed in. How do I give permission to you online? Phone to. Oh, man. bet. Coworker works now. Oh, and Ubuntu. Okay. We gave it 25 gigs. I still need it more. How much space do you need? Let's see if I can add some more disk space real quick. Sudo shut down now. Still kind of close you a long time. All right, let's do this. Hardware. I will save more time just redoing this and building this again versus trying to go through all these correction steps. And I really want to get this working. So it's only, well, I guess it's almost 1 in the morning. This is a long stream. Let's create a virtual machine and Claude AI 01. And resource pools. Oh, let's turn off advanced. Let's give it too much. All right, resource pools. Harness nest next. ISO image. Ubuntu 26. Linux UC. Yep. And machine Q35 BIOS EFI. Local storage. All right, and then disk. Let's go 65. And 2 cores. 8192. Confirm. Start after created. Finish. Console. All right, now we got to go and delete that last entry because I don't know what IP address it's going to get or what unique MAC address it's going to get for my router. All right, let's go ahead and delete that entry. Oh, I really like the IP address of 1.10. It was very convenient. All right, we're doing an install of Ubuntu 26 so that we can use Claude Copilot beta on here as virtual machine. All right. Just doing all the default selections. Oops, let's go back. We do want to install the third-party software for graphics and Wi-Fi hardware, and then download and support for additional media formats, of course. Yep, we'll do the erase, no encryption, and we'll make this, what was it, Claude. right. I'm gonna go ahead and do this install. All right, this is taking a little bit of time, but we're still getting there. So I guess that's all that matters. Oh, this is really taking a while. All right, we've got that installed, and we're going to go ahead and do a restart now. Hello, chat on our message board. How nice. All right, press enter. Okay, now that that server is up, I am going to first get the MAC address of this server. So I'm going to go over to network device, edit, grab the MAC, copy that, and just go through all of this. Of course, we're going to put it in dark mode. Accent color is orange. We already like that. And finish. And then I'm going to open up a terminal. Gonna get my IP address, IPA, and it pulled 28. All right. Earlier it pulled 10, and that was very convenient. We're gonna add that to our router. And I know I can change it, but I am doing this for speed. All right, so off screen, what you can't see is me adding this to the router because I want to make sure, just keep some of my information, you know what I mean? And we're going to name this Claude. I'm going to go ahead and add that in there. Now, what I need to do is clear out and do sudo apt install SSH or open SSH server -y. And then I'm going to do systemctl enable --now SSH. What in the world? There we go. Okay, and now I should be able to use Visual Studio Code to SSH into this machine. So I'm gonna clear out and SSH what was it? Claude at 192.168.1.28. Yes. Type in the password. And now I'm ready to make my configurations to have Claude installed. And we're just going to copy and paste these commands from Claude itself. All right. And basically installing the curl package and then the packages that are needed, or the repo that's needed for Claude application to be installed, and then installs the desktop application itself from the repository that it just configured. All right. Now that we have those details and packages added, I should be able to open up Claude, the desktop application. All right, and we're just gonna ping google.com on one page. So I'm gonna open up Visual Studio and turn off my browser real quick. I'm just gonna ping google.com while I input my personal information on the other screen. Thank you for your patience. All right, and that was a success. So now let's try co-work. All right, still getting similar issues. So let's plug this into Claude. Nope. Okay. Hardware, processors. Oh, I guess I didn't set it to host. Oops. I thought I did. All right, that's most likely going to require a reboot. Yep. Console and terminal. So when I created this server, I didn't set the CPU correctly. In order for it to take, I'm going to do a reboot. All right, and let's go ahead and log back in. And we're going to open up Claude. Yeah, let's try co-work. Same issue. All right, it says let's do confirmation down here. Let's do that with Visual Studio Code. Oh boy. Okay, looks like I'm gonna have to do another rebuild. Let's just get this going. All right. Or do I? Let's see. What else is this? No. Basically, I just built this wrong. I'm not gonna go through all that trouble of how do I? Let's just power it off and build it again correctly. All right. Get that powered off. And boy, oh boy, that means I gotta delete this entry again. Delete. All right, and then on here, I'm gonna delete this. So we're gonna go to more, remove 1, 2, and 104. Now I'm gonna create a new VM. Claude AI 01. OS Ubuntu. Oh, let's do it like this. All right. Creating a virtual machine for Claude AI to run on Linux beta. I'm gonna name it Claude AI 01. The ISO image we're going to use is Ubuntu 26.04, the desktop x84, and then this system, I'm going to change that to Q35, BIOS, UEFI, local logical volume management. The disk, we're going to make that 65 gigabytes. The CPU is going to be 2 CPUs, 2 cores, and we're going to run that on the host. And then memory is going to be 8192. The network we're going to leave default, and we're going to start this after boot. Thank you to the subscribers that are subscribed currently. If you like the content and enjoy, please like, share, and subscribe. All right. Okay, let's begin our graphical user interface GUI installation. We're going to use English as our language. A lot of defaults here. We're going to install the third-party software and download and install support for additional media formats. We'll erase the disk and install Ubuntu. No encryption. The name for this is going to be Claude, and password. All right, let's go ahead and do this install. This takes a while to install, and this is going to be a snippet that is uploaded later on. So for those of you who are watching the video later on, thank you for tuning in and being patient through this portion. And I will include the timestamps so that you can skip over this portion. But if you are watching, thanks. All right, it's setting up the system now. So we're almost at the point where we can reboot and configure our SSH, and then we'll install Claude, and then we'll configure Ubuntu to work with Claude Cowork. All right, we're ready to restart. Let's go ahead and do that. Now, one little thing that happens with the reboot is you're going to have to press enter. And sometimes it just hangs. You don't know why it's hanging. It's because you got to press enter. All right, there it goes. All right, welcome to Ubuntu 26.04. Oh, previous, dark mode, next, finish. Now we're going to go to hardware and network device, edit. I'm going to grab this newly generated MAC address. I'm going to put that into my router along with the IP address that this was given. I'll check the IP address using IPA, and I can see the IP address is 29. So let's actually nmtu sudo nmtu oops control C sudo su nmty let's see if we still got the same IP. I don't like that. 29. Oh boy. For the sake of time and for the sake of this video, I am going to, man, I already messed up the video. All right, whatever, man. We're just doing this just to do it now because it's not a clean video anymore. Okay, whatever. We'll still post the video, and nobody's gonna watch it. Then nobody watches it, and somebody watches it. And somebody watches it. All right, I've got my server added to my router. Now, I'm going to make this much bigger. And I'm going to do apt install open SSH server and then systemctl. Actually, let's just do that first, -y. Then clear out, then systemctl enable --now SSH. And now I'll be able to use Visual Studio Code to SSH to 29. Yes. All right, and elevate my privileges. Actually, there we go. Let's do this again. All right, we're going to Install Claude. All right, adding the user to the KVM. And then we're gonna do a reboot. Reboot now. Okay. Oh. Oh my goodness. Jesus. How about you just shut down? If I'm root and I'm saying shut down and you still tell me you don't want to shut down, take a breath. Whatever. All right. Let's get Claude working and open it up. We're going to have to sign in. And while we sign in, I'm going to put up another page. All right, and then let's go ahead and hide my internet browser for a second. And I'm going to go ahead and log in to Claude. All right. We have Claude open and we're logged in. Set up agent mode. Download a one-time package to give Claude a secure workspace on your computer. Download. And it looks like Cowork is working now. What cool things can you do now that you have access to my Ubuntu 26.04 VM server with Cowork? All right. We have a working configuration. So to summarize this, I went to hardware. I have two CPUs, one socket, 8 gigabytes of memory, Q35, UEFI. I ensured that the CPU was nested to the host. So if we go to processors, edit, the type here is host. And then what else was important in this build out? The ISO image that I used, it required me to change the permissions for SSH. Other than that, I can show my history, and that'll show what I did as far as changing and modifying the system so that cowork would be able to function. And one of the key things that I had to change on this server was ensuring that it had enough memory, or not enough memory, but enough storage space for cowork to work, or for cowork to operate. And that was 25 gigabytes minimum, but you have to also compensate for the OS, and that's going to be like another 10 gigabytes. So really what I did was just to ensure that I had enough headspace. I gave this server 65 gigabytes worth of storage space. So I'm going to SSH Claude at 192.168.1.29, and I can do a history. And you can see here, I did an update. I installed curl so that I could download the strings and the packages. And then I did the install for Claude Desktop. And then you have to modify the KVM for the user that's going to be using Claude Desktop. And then to apply the changes, you have to do a reboot. And that's how you get Claude Desktop to work on Ubuntu 26.04 with Copilot or Cowork enabled. Oh, I forgot I'm still streaming. Anyways, I'm just trying to get Cowork to do cool stuff now. List connected browsers. List _ connected browsers. I've got to update my music. So much of it sounds kind of sad. And it's not the vibe I like. All right. Thank you all for watching, and I'm going to do this without